Hello everyone, welcome to session 1, chapter pressure. The objective of this video is to define and differentiate thrust and pressure, to verify Pascal's law, and to solve numerical problems based on Pascal's law. Before we go to pressure, let me talk about thrust. Thrust is a kind of force which is applied on the surface perpendicularly. So that particular force is known as thrust. So here you can see this force is applied on the surface perpendicularly. So this kind of force is called thrust. That is why the definition of thrust is the perpendicular force that is applied on the surface is known as thrust. And since it is force, its SI unit is Newton. So after defining thrust, the pressure is defined as this thrust, this special force. Thrust per unit area is known as pressure. And according to definition, the formula pressure is thrust means force per by area. So formula pressure is force by area, and its SI unit is Newton by square meter. That's why SI unit is Newton per square meter or Pascal, and CGS unit is the CGS unit of force is dyne and area is square centimeter. That's why CGS unit of pressure is dyne per square centimeter. And it has only a magnitude but no direction. That's why it is scalar quantity. Define 1 Pascal pressure. So to define such question, always we have to take the alpha formula. So if force is 1 Newton and area is 1 square meter, then the resultant pressure is always 1 Pascal. That is why if 1 Newton thrust is applied in 1 square meter area, then the exerted pressure is known as 1 Pascal pressure. Just now we discussed about thrust and pressure. So if you have to differentiate them, then the first point is their definition itself. Thrust is the perpendicular force that is applied on the surface, whereas pressure is the thrust per unit area. And since thrust is a force, so its SI unit is Newton, whereas SI unit of pressure is Pascal. And thrust has both magnitude and direction, so it is vector quantity, but pressure has only magnitude, that's why it is a scalar quantity. And because of thrust, pressure is exerted, so that's why thrust is cause and pressure is effect. Pascal's law. So this is a law that is explained in enclosed vessel containing liquid. So if we take any enclosed vessel containing liquid inside here, and if we press it, then from all the holes, the water will come out with the equal rate, means equal pressure. That means if you apply the pressure, then the pressure is transmitted in all direction equally. So this law is propounded by a scientist known as Blaise Pascal from France, and it states when pressure is applied, when you apply the pressure here in enclosed vessel containing liquid, that pressure is transmitted in all direction equally. And this law is applicable in both liquid and gas. And there are so many devices like hydraulic press, hydraulic brake, hydraulic lift, etc. Their working principle is Pascal's law. Hydraulic press. So this device can multiply the force. By applying a small force, we can lift a large car or heavy car. So that is why hydraulic press is a device which can multiply the force. And its working principle is Pascal's law because it is enclosed vessel containing liquid, and whatever the pressure is applied here, same pressure is created here. And here we have some numerical problem. This is a enclosed vessel containing liquid having three pistons ABC. So according to diagram, the area piston A is given 40 square centimeter, means converting into SI unit, you have to divide by 2 times 100. So it becomes 0.004 square meter. Area piston C, so AC, A means area, C means piston C, 20 square centimeter. So dividing by 102 times, it becomes 0.002 square meter. And force on piston A, F means force, A means piston A, is 400 Newton. Similarly, force on piston B, FB is given 600 Newton. Now, going to question, what is asked is area piston B. We don't know the area piston B, that is asked. Similarly, in piston C, how much force is created, that we don't know. That is what asked. So according to Pascal's law, what it has said that whatever the pressure is exerted, equal pressure is transmitted everywhere. That means whatever the pressure is created in piston A, same pressure will be created in B, same pressure will be created in C. So right now we are going to solve the question of piston B. That's why we compare piston A and piston B. That means the pressure in piston B A is equal to pressure in piston B. In that case, pressure in piston A means force on piston A by area piston A, because formula pressure is force by area. So pressure in piston A means force on piston A by area piston A equal to pressure in piston B means force on piston B by area of piston B. So keeping the values, force of piston A is given here 400. So by area piston A is given here 0.004. So let's keep that value equal to force on piston B is 600 by AB, area piston B, it is asked to us, so we kept the same area piston B. So doing cross multiplication, the result is 0.006 square meter. So area piston B is 0.006 square meter. Now going to force on piston C. So piston C means here. So now we are going to compare with piston A with piston C, or we can compare even piston B and piston C, it will be same. So whatever the pressure is created in piston A, it will be same in piston C. So that's why pressure in piston A equal to pressure in piston C. So pressure in piston A means force on piston A by area piston A equal to pressure in piston C means force on piston C by area piston C. Now keeping the values, force on piston A means 400 and area piston A is 0.004 equal to force on piston C is asked to us. Area piston C is given here 0.002. So doing the cross multiplication, the result comes force on piston is 200 Newton. Now going to another type of numerical. So this is the diagram of hydraulic press. So what question is saying that a force of 2 Newton is applied on the piston of area of 10 square centimeter. What force is obtained here in the piston having area 100 square centimeter? So it is also based on Pascal's law because it is enclosed vessel containing liquid. So let's go to solution. So force of a small piston is given here 2 Newton. So force on small piston Fs, force on small piston equal to 2 Newton. Area of small piston As equal to 10 square centimeter. So converting into square meter, divide by 102 times. So it comes 0.001 square meter. Similarly, area of large piston 100 square centimeter. So AL, area of large piston is now dividing by 102 times. It comes 0.01 square meter. Now question is asking what force is obtained here. So force on large piston FL equal to what? So according to Pascal law, the pressure created in small cylinder is equal to pressure created in large cylinder. That's how we can say pressure on small cylinder equal to pressure on large cylinder. That's why pressure on small piston means force on small piston by area of small piston equal to force on large piston by area of large piston. Now keeping the values, force on small piston is 2 Newton, so 2 by area of small piston is 0.001 equal to force on large piston is asked to us by area of large piston is 0.01. So during the cross multiplication, force of large piston comes 20 Newton. So hence required force on large piston is 20 Newton. Here you can see we applied 2 Newton force, and by applying 2 Newton force we could produce 20 Newton of force. That means this device helps to multiply the force. So with this we want to wrap up session 1 of chapter pressure. Thank you so much.